Okay, so in the previous video we concluded that the alternating harmonic series does converge. Now the question of what it converges to is something that's going to have to wait for a while. We actually kind of hand waved my way through one little piece of it. Since the odd sums is bounded and it's monotone, it's always decreasing. We know it will converge. And since the even sums are bounded, and in this case they're always increasing, it will converge. The question would be, is it the case that these two things will converge to the same thing? Turns out that answer is yes, but that is actually something that does need to be verified. We're just not going to bother with that step, concerning ourselves with that, but that is something that also does need to be considered. But it turns out it will converge to the same thing. Both of them do. So it does in fact converge. This brings us to a result that's kind of based around this alternating harmonic series. And that is something known as the alternating series test. That lets us, not just for a series like the alternating harmonic series, but any alternating series. So the alternating excuse me, series test says that if you have an infinite series, here I'm just going to say k equals 1 to infinity, but it could be k equals 0 or k start at 2 or any other value. Where we have an alternating sign, it could be minus 1 to the k plus 1 or minus 1 to the k, either one. And then times some expression ak, where there is one requirement on the ak, where the ak are positive, at least beyond a certain point. Okay. What matters again is the tail end. So beyond a certain point, they're positive. So if the first couple terms, it's not, even the first 100 terms, some of them are negative, some are positive, that's okay. As long as beyond a certain point, they're always positive. Okay. So sequence where we have a set of positive terms, or positive underlying sequence AK with the alternating series. We say this series converges if two things are true. If two things are true. One, the terms of A sub k are non-increasing. Okay. In other words, they need to be mostly decreasing. They need to be mostly decreasing, but we allow for the possibility that sometimes it takes on the same value. But the terms are non-increasing. Non-increasing. And number two is that the limit as k goes to infinity of the a sub k's needs to go to 0. Needs to go to 0. So two things need to happen. Actually, technically three things. We need to be dealing with terms that are positive, at least, again, beyond a certain point. And again, beyond a certain point, the terms of the sequence, the underlying sequence AK, need to be non-increasing. Need to be non-increasing. Typically, we're going to be looking at ones where, for the most part, they're decreasing. Of course, decreasing is a special case of non-increasing. And then the limit needs to go to 0. The limit needs to go to 0. This condition number 1 is a condition that's not super important for us. So it turns out if you get special sequences where you have this, the terms at times can be increasing, and you can still have the limit going to 0, then you can actually break the convergence. You can actually break the convergence. But you have to get really kind of complicated, somewhat complicated anyway, underlying sequences to cause that to happen. And so for us, pretty much for the kind of sequences we're going to be dealing with, if the limit of the underlying sequence goes to 0, the alternating series is going to converge because the ones we're going to be looking at, since the limit goes to 0, that kind of makes the terms, at least beyond a certain point, have to be non-increasing, and so therefore we go, since it goes to 0, right, then we're okay for the most part. So, but this is something that can be more of a technicality that you can run into in a more advanced class, where you would look at this situation here. Okay, but for us, we're going to, for the most part, it's going to come down to if the underlying sequence goes to 0, then in the alternating series, for the most part, they're going to converge. Again, technically, we should also consider this case, but for the ones that we're going to be looking at, that's really not going to be an issue. That's really not going to be too much of an issue. Okay. So, in other words, for the infinite series AK, limit as k approaches infinity of the AK equals 0 does not guarantee convergence, right? We saw that, right, with the divergence test, right? That was an inconclusive situation. Right? It does not guarantee convergence. But with a non-increasing sequence of AK, but as long as we have that non-increasing sequence, but for the alternating series, minus 1 to the k plus 1, AK, it does guarantee convergence as long as, again, we have this non-increasing sequence, as long as AK is a non-increasing sequence. Okay. So that's something we're just kind of going to have to observe in some of our examples, that it is non-increasing. There is one we will look at where we will use a little bit of our calculus to kind of make that observation. But a lot of times this is something we're going to be able to kind of observe really quickly just by looking at the sequence. Okay, so this is called the alternating series test. And again, for the most part, the main test for us is just going to be, does the limit go to 0? Again, we do technically have to consider this other case, but for the kind of functions series we're going to be looking at, this really isn't going to be an issue. If the limit goes to 0, then this part's going to actually also necessarily have to be true for us. But just want to be complete that there are sequences you could create where the limit goes to 0, and you have a sequence that isn't non-increasing. You can actually have it not be a convergent series. But again, that for us is not going to really be much of an issue. We have to get into something really complicated, or pretty complicated, to cause that to happen. So for us, that's not going to be an issue. So here, limit, for us, for the most part, we're going to be just looking at this. But we will keep this idea in the back of our minds as well, to make sure that that is checked off as well. Okay, so that's known as the alternating series test. And so it's much easier to check convergence for an alternating series, than it is for a regular series.